Hi there. This time I bring to you a problem which involves drag. So we have an object of mass 5 kgs being thrown up. And in another scenario, the same object is released down from the same height, mind you. So this is going to reach a height of x and then start descending back, right? And this is the descent, and this is the ascent. We're not given the initial velocity, but what we're given is there is drag, air resistance of 10 newtons. And what we need to find out is the ratio of the time of ascent to the time of descent. It's an interesting problem. Let's see how to go about it. I'll give you a couple of minutes to take a dig at it yourself. All right, if you've paused and taken a dig at it yourself, now I'll show you how I'll go about it. So let's draw the free body diagram. During the ascent, there is mg, which is 5 times g acting down. And remember, drag always acts opposite to the direction of motion. Drag's going to be pulling down as well. And the drag of 10 newtons added to the gravity, 5g. And this will give you the net acceleration. So what I'm going to write here as the equation is 5g plus 10 newtons equals 5 times a. And I'm taking a downwards. And I'm going to take the value of g as 10 meters per second square. So this becomes 50 plus 10, 60 equals 5 times a. And I get a equals 12 meters per second square downwards. Right? Now, let's say it starts with an initial velocity of u. So what happens now? We reach the top and the velocity goes to 0. So 0 minus u upon, let's say, the time of ascent is ta. This is going to be the net deceleration. And this is equal to minus 12. So from here, what I get is u equals 12 ta. And going further, when I apply this to calculating the distance of the displacement, I get x equals uta minus half times 12 times ta square. And substituting u as 12 ta, I'm gonna get 12 ta square minus 6ta square. And that's equal to 60a square. So that's an expression for x. Now we'll analyze the descent part and get an expression for distance or displacement in terms of td. Let's see what happens here. So during the descent, the equation of motion is going to be x equals half times acceleration of descent acceleration times td square. Now, what is the acceleration during the descent? Let's find out. Let's make the balanced free body diagram. So we have mg acting downwards, 5g. And this time the drag is going to be acting up because it acts opposite to the direction of motion. So what we have is 5g minus 10 equals 5a. And this gives you 40 upon 5 equals a, or 8. Now that we have established the downward acceleration is 8 meters a second square for the descent, we're going to go back to this equation and say x equals half times 8 times td square. And this is equal to 4 td square. Now I can see x is equal to 60a square and x is also equal to 4 td square. And hence I can say 60a square equals 4 td square. And this will give you the ratio of ta to td as root of 4:6 or root 2:3. All right, thank you. I hope you had fun with the problem. More such problems coming your way soon.